Hello world, this is Byte Relay. I got my new cool standing desk and I decided that it's just about the time to make a new episode of Hacking Postgres. Uh, and today let's talk about very simple debugging techniques. Uh, and specifically about debugging segmentation fault. Usually you just want to, there are very complicated and very difficult cases, but usually you have to start from somewhere. Let's induce segmentation fault. Uh, Here I have code. Let's run configuration and open Visual Studio. Like debugging backend that encounters segmentation fault is relatively easy to start because you can attach debugger and find the place where you hit zigzag. But in many cases, you encounter segmentation fault in some auxiliary processes. Let's start with background writer. Here is the code of background writer that is forked from postmaster, and here is a background writer main function. And let's find a good place to induce core dump segmentation fault here. Here is a main loop, and after one iteration is complete, let's do a core dump here. Well, not core dump. Core will not be dumped. We will just see what's happening. So we want to we can dereference null like that. But this is dirty and can be optimized out, and I personally like the easier way. Raise Let's try to build such a binders with this error. So it had compiled. We can run cluster initialization like that. Initialize new cluster and started it, attach PSQL to it. InitDB runs just fine, and then we get an infinite loop of crashing background worker and restarting Postgres again and again. Let's stop it. What happened? We see that there was segmentation fault. What exactly was happening? It's difficult to attach debugger to this particular process because it is forked from postmaster, then it's encountering segmentation fault, and then it's over. There is no time frame when we can safely attach our debugger. What to do in this case? Recently, I've encountered a patch that was written 5 years ago by Peter Eisentraut here, and the patch is named mock backtraces. It was discussed that we would like to see backtraces when it's possible, and I really like that idea. It could help us debugging segmentation faults in auxiliary processes like background writer, checkpointer, and all their friends. Unfortunately, patch was not committed. It was discussed and there were some plus ones. So let's see what the patch is doing. In it's in postmaster C, adding a abort handler that will print backtrace symbols into standard error stream, and this abort handler is attached to SegBus, and SegAbort. SegAbort is particularly called by asserts, which are actually printing backtraces. And we can see that this case is handled in the patch. Print from exceptional condition of assert is removed. So what should we do? Of course, we should rebase this patch. Let's do it. Something went wrong. Okay, everything's fine. We want the patch. We are now on master branch from vanilla Postgres. We are in detached head mode. Let's try to apply that patch with 3 web merges. Bring backtraces. No single file was cleanly applied. Of course, that's kind of anticipated. Let's see what went wrong. Here we see some kind of a conflict here. I think we should just make something like this. By the way, this is a very interesting feature. We can define sleep on assert. So if we want to attach to fail at assert, we can do it. But that's not what we are doing now. Okay, file assert C is rebased. And what left? Postmasters, of course. Of course. Let's start from the beginning of the file. I have no idea what's going on there. Here. It looks like a change that's simply adding some header files, or just accepting common headers. Just check that it's not defined anywhere else in the same file. Looks like it's C files, it's used only in elog. Okay, we have backtraces in elog, so it looks like a valid usage. Let's go on with conflicts. Here, conflict of static files. Perhaps we need only this one function, abort handler, and nothing else. Let's just cite it near other signal handlers, and they have a very different form. It's named handle, postmaster, signal. Okay, let's cite it near dummy handler. It has more similar name. And there is a macro for arguments. It's using not a signal argument, but Postgres signal argument. Okay, let's do it similarly. Here we add this handler 3 times. Let's repeat it in modern code and make it look similarly. Strange. That was all conflicts. Seems easy. Let's try to compile it. No, it doesn't work. Signal functions seem to be different. Board handler. Let's see if dummy handler, signal arguments, and the board handler. Of course. Signal arguments and Postgres signal arc. Okay, should work now. I hope. Inside the board handler, we are raising the same signal again, and we must do it with a new function queueSignal. I got it. Let's try to build. Seem to work now, and without warnings. That's great. Let's try running our installation again. We have the same cycle of running background writer and hitting segmentation fault. But now we can see where exactly our stuff happened, and we see that signal handler was called from background writer main, and we can debug it. Perhaps let's finish. Patch rebase. We don't want to add our changes to the patch here. And we actually want to add our changes to postmaster. Git and now let's see it. Okay. A commit message looks the same. Let's see the diff. I don't see anything particularly wrong. Patch format 1 and looking to this thread, I think it's second version of a patch. Perhaps I think we can send this patch to as a response to first message. Let's find this. So this is version 2 of a patch. Format patch 1 patch version 2. Wait, format. More backtraces. Trying to find it in PGSQL hackers and reply to start as a thread. So I find this patch. I can. So let's basic version in archives. It would be great to have some things. I don't know how to express it politely. That would be great if it would be committed. It would greatly help debug stuff on production servers. Could help collect. Don't like this warning. And I'm going to have something like. Okay. Let's see that we are sending correct patch. Looks good. Don't see anything wrong with it. Okay, that's it. So with this simple patch, you can easily trace root cause. Well, in some simple cases of segmentation faults. That's it for today. Thanks for watching. Bye.